Yes.
Okay. Okay, thank you. Hello, everyone. This is Greg from the zkMove team. I will represent the team to give the small presentation. zkMove Azure is a trustless computing service built on Move. Okay, the problem we are trying to solve is that currently the apps cannot access data outside the blockchain, which include historical on-chain data, external results, and private data. While there are already some solutions, they either require trust assumptions or are not scalable or not programmable. Okay, our objective is to resolve this problem. So what is zkMove Azure? It's a trustless computing service designed to extend the feature set of the blockchain. It enables dApps to access on-chain historical data in a trust-free manner. It also enables dApps to access any external resource with minimum trust. It allows arbitrary computations to be performed on the data. Besides, it also enables developers to create customized zk applications using the Move language. Their applications can be integrated with other zk modules and seamlessly deployed on the chain. Okay, how does it works? Here is a rough architecture. The left side is the publishing process. Developers can create arbitrary move scripts and publish them onto the registry through the zkMove SDK. On the chain, there are 3 small contracts: the registry, front end, and verifier. dApps send a request to front end to trigger an event. The zkMove VM listens to the event, read the corresponding script from the registry, execute the script to read the historical data or external data and process the data. Then send the execution witness to the prover to generate a zk proof. Then the proof is sent to the verifier. Finally, the dApps get the verified results. Okay, zkMove VM is a zk virtual machine. It's fully compatible with Move language, with Move spec, and is the first zk VM with runtime type safety. It supports transaction level concurrent proven with very low latency. Historical or external data is provided as a separate circuit that can be plugged in as required. The circuit can be proved in parallel with the main circuit. The prover eventually aggregates the proofs together and to generate a proof. Okay. Some things needed to be clarified. Azure is a layer 1 infrastructure. It's not a layer 2 rollup, because we want to extend the blockchain's feature set and not to scale up blockchain like rollup. We want to be part of blockchains and utilize the blockchains and not another blockchains like rollup. We are not holding users tokens. If possible, it will only charge minimum service fees to DApps. Okay, to help build the Move ecosystem, zkMove Azure is preferred to be deployed on Aptos in the SUE. It can also be deployed on Ethereum and even on all kinds of layer 2s. Here is our roadmap. This project launched in July this year, and we have a very preliminary POC on October, and we will have a first release in next year, in March of next year, and we'll have a testnet running in the middle of the next year. Okay. About the team, we are a small, fully distributed team. We leverage underlying blockchain infrastructure to create value for users. The long-term goal of the team is to combine zero-knowledge proof technology with the Move language to create safe, efficient, and trustless protocols to enhance blockchain capabilities. Okay, thanks.
Okay, thanks the presentation from zkMove team and from Greg. And now we'll have our judge, Josta, to ask one question for the zkMove team.
Hear me?
Okay.
Hey. Can you hear me?
Yeah, we can hear you.
Yeah. I want to ask two questions. One is, can you give some example for the external resource? It can be another blockchain or some which type of external resource it support. It need some the root things on the blockchain or just raw data.
Okay, good questions. There is a, let me show the slides again. Yeah, you can see here is a list, and we have some scenarios can be served by Azure. For example, trustless oracles. You can the DApp can get an average price of a range for a token or for some how to say, coins. And another category is identity. With Azure, the DApp can get a loyalty of an user, and even can get a participation-based airdrop to find out the users really participate in the app. Okay, this is the typical scenarios for historical data. Yeah, for external data, currently there is actually much broader, and we are still in the early stage to explore it. We do this through a plug-in mechanism. If the external data can be stored in a Merkle tree, then its circuit can be automatically generated by zkMove. If it's a customized storage structure, then we have to generate the circuit. The developer have to generate the circuit by themselves. It is possible to use the tools provided by Hello tool to write their own circuit, which the circuit will eventually be aggregated with the main circuit. For example, we can build a scenario that to access commit information in the repo on GitHub. To implement this scenario, first we need to use Rust to implement the read operation of the repo. Second, we need to implement the circuit for the read operation by using Hello tool. Yeah, this is some rough idea for how to integrate the external data. We haven't studied really implement the solution yet. It's still in a very early stage. We are full effort to implement the main structure currently.
Okay, thank you.
Okay.
Okay.
Is there any more questions?
Another question is, I want to ask is about what is the hardest part to implement a ZK solution to generate smart contract VM like Move language. Yeah.
Okay. For the challenge, yes. As we know, the Move ecosystem have a very weak zk infrastructure currently. For example, Planck on-chain verification is not even available, and we have to build it from scratch. And recently, we were building Hello True Verifier with Aptos. It needs to start from very basic elliptic curve BN 254. It's very challenging. Another challenge is performance. VM design needed to be improved, and aggregation, hardware acceleration, optimization of the underlying proof system, exactly, and a lot of work needed to be done. Our strategy is to get it working and then let it evolve. We can start with scenarios that doesn't require a timely response, then improve the performance to support more and more requires in a timely manner. Okay.
Thank you.